Hello, everyone. This is Kevin Eureka. I'm an OCI security product manager, and I'm here to talk to you today about security zones. We will go through an agenda that looks like this. We'll talk about the high-level positioning of security zones. We'll talk about our new release and the features and capabilities of the new release. We'll talk about security zone use cases, why it's important, how you might want to use it, why you care. And we'll talk about customers. I'll give you a demonstration, and then we'll have time for questions and answers after that. But let's jump right in to the high-level positioning of security zones and where it fits within the OCI security portfolio. So if we consider a defense in-depth perspective from data to the edge, there's an array of OCI security products that are designed to keep your cloud tenancy safe. And there's, from a category perspective, a number of different areas that are important to you. Security zones fits in the lower right under monitoring and prevention, along with a number of other OCI security products that we'll also touch on. If we flip the view from security zones to category, and we try to double click on the positioning of security zones within category, we end up with security zones and CloudGuard fitting within a category traditionally known as security posture management. And security posture management is an established category that's been around for more than 5 years. But let's consider that category today, where it is and where it's headed before we go too deep into security zones. And so if we consider Gartner's view on CSPM, they will tell us that cloud security posture management is very, very relevant today. It's very much in the diamond of things that you need to care about, and it can offer real advantages to your cloud security. You should pay attention to it. And the reason they say that is because they predict that 99% of cloud security failures will be the customer's fault for the next several years. So if we think to ourselves, okay, if CSPM as a category is there to help secure customers' tenancy and to guarantee an appropriate cloud posture, what are the changes around that category and where is it headed? So there's a new umbrella category called Cloud Native Application Protection, or CNAPP, that is enveloping cloud security posture management and a number of other additional product categories. And so it doesn't really change the core function of what CSPM is intended to do or the value it delivers to you, but it's essentially an umbrella category that you'll hear more and more about. And CSPM is one component within this new roll-up category that you'll want to pay attention to going forward. I think you'll hear much more about it in the years ahead, and it should be on your radar screen. So if we consider the new release of Oracle Security Zones, it was released in May 2022. There's a number of things that we think are really important about security zones. Number one, it prevents weak configurations. Security zones is designed to prevent bad errors or malicious actions that would weaken your cloud security posture and cause you problems. Security zones also allows you to select policies, and the primary mechanism for defining security settings within security zones is this idea of security policy. So a security zone is a collection of security policies designed to fit your particular needs in cloud tenancy. The third point, which is important, is that Oracle Security Zones is about integrated posture monitoring. Security Zones as a product is designed to work with the adjacent security services to provide an integrated view and an integrated security functionality that allows you to secure your tenancy, not only with respect to security zones, but to integrate and connect with adjacent security services so that you've got essentially a security fabric and you're not looking at a single product running in isolation. if we, leveraging that concept a little bit further, when we introduced our new release of security zones called custom security zones, we did it as part of a group or basket of 5 different products. We introduced network firewall security zones, threat intelligence service, threat detector, and Fusion apps detector into a simple onboarding example where a customer is coming to OCI and needs to set up security across their entire tenancy. And the reason I'm bringing this up is because one of the benefits of OCI security in general is the ease at which you can set up and create a secure environment for a new tenancy quickly, easily, and with all of these different services working in concert. So security zones is certainly part of the OCI security fabric, and it's designed to work with the adjacent services around it. And so if we think about, hey, what's the high level fit for security zones relative to some of the products around it? Security zones is designed to enforce resource-based policies and is constantly, answering the question, is this action allowed? So if you're trying to change a virtual machine, if you're trying to introduce object storage buckets to your tenancy, security zone policy, once applied, is going to look at the action, the control play action you're trying to take, and is going to ask the question, is this allowed based on the security policy applied to this compartment or set of compartments? Reflecting that same security posture is CloudGuard, which is doing monitoring on the exact same policies that security zones is enforcing on. So the duality between CloudGuard and security zones is a key part of our implementation here. Both services rely on the same object model behind the scenes. Security zones is enforcing security policy. CloudGuard is monitoring that same security policy. And together, we talk about them essentially servicing both sides of the same CSPM coin, providing true enforcement plus verification of your security policy, where you need to set it just once. So you set the policy in security zones, you get the CloudGuard monitoring automatically configured on top of that to give you additional assurances. On the far right side, we've got identity and access management, and certainly permissions for accessing cloud resources are very, very important. Security zones and CloudGuard have a connection to identity and access management that's important, but security zones are not easily defeated by privilege escalation or other hacks that might be propagated in the IAM world. So security zones provides an additional layer of protection against permission-oriented attacks. And I think that's one of the reasons why it's so popular with our customers now. So for those of you that might be familiar with a little bit of the history from maximum security zones to custom security zones, I think it's sort of worth replaying what's happened here. So maximum security zones was released in September of 2020, and it really proved the concept and utility of security zones. However, there were some challenges with the product around immutability, where we supported absolute immutability, which kept people from making changes once they applied security policy. And what we found was that it was very easy to sell the benefits and the concept to customers. Unfortunately, there were usability issues associated with absolute immutability that we had to address in this new release. And so for the new release of May 2022, custom security zones broadens the scope and addresses these usability issues and provides flexibility in a number of different ways. The first way it provides flexibility is it enables users to select or deselect the policy statements required to support their particular situation. So the old MSE model applied a very strong security recipe, didn't provide customers the flexibility to tailor that policy set to their own particular circumstance. You can now select and deselect any policy statement that you want from a policy set and apply it very, very easily. The second change that we made was we removed the limitation that security zones could only be applied to new and empty compartments. So originally, the maximum security zone implementation, forced you to create the security zone before you populated the cloud infrastructure so that we'd have perfect visibility to everything that happened in that compartment. We found that that wasn't particularly practical, and customers wanted to be able to apply security zones to any compartment, whether it had infrastructure or not in it. So we changed the product to allow it to be applied to any compartment at any time. We also changed the back-end object model so that security zones and CloudGuard essentially are operating from a shared common model. And if a CloudGuard detection occurs on a particular, compartment that says, hey, public bucket found, the security zone rendering notion and identity of that particular problem will match CloudGuard exactly. So there is no semantic difference between what CloudGuard sees and thinks and what security zone sees and thinks. These two things are working in concert all the time due to the common object model on the back end. We added API support to security zones so that you can now access it programmatically through the API, CLI, or SDK. We also added Terraform support so that people that are, essentially developing very large implementations and they need to have patterns that they can execute programmatically to build out customer tenancies, all of that's supported. So why do you care? What are the use cases where security zones might help you? There's really three primary use cases for security zones. The first one is probably the 80% use case for Oracle Cloud customers that are in retail, that are in healthcare, that are in manufacturing or many other industries. Security zone guardrails provides a way for them to prevent employees from making bad errors or malicious actions from being taken that would potentially expose their sensitive data to the open internet. And so guardrails can be applied to any compartment or set of compartments, and they can be fairly mild policies that like no internet gateway, no public buckets, no database without backup, or they could be much more restrictive depending on the goals that the customer has for their particular tenancy. The second use case that's very important to Oracle internally is application protection. There's a lot of software as a service applications that run on top of Oracle cloud infrastructure. Those SaaS applications essentially benefit from all of the underlying IaaS security controls that we provide. Application protection is a place where the benefits of Oracle security products at the IaaS layer are being realized by the application developers within Oracle who need to provide NetSuite, Fusion apps, or even PeopleSoft applications that can essentially benefit from the security controls that are offered at the IaaS layer. And the third use case is around enhanced security. And there's certain customers, government customers, banking customers, even manufacturing customers with very sensitive IP that really want to enhance security in certain areas of their tenancy so that certain data is prevented from ever seeing the public internet. And the enhanced security policies that security zones offer allow you to set up strict rules that help protect your sensitive data. Now, if we think to ourselves, hey, there's a lot of cloud security posture management tools in the marketplace. There's third-party tools that offer cross-cloud capabilities. What is different about security zones relative to these other tools? And I think, in the lower right, you can see enforcement shown in red. But the idea of enforcing security policies is generally very difficult for third-party tool vendors because they don't have the hooks deep into the stack. They can't intercept control plane operations that the cloud provider can. And Oracle is able to go, since we own the entire cloud stack, we can take actions at any layer in the cloud stack that we want, and we're able to enforce control plane operations very, very effectively, which is something that would be very hard for a third-party tool vendor to do. So if we double click on each of these use cases a little bit deeper, the first one, applying guardrails to prevent bad errors, really is about protecting resources and keeping any action in a customer tenancy from weakening the security posture or configuration of that tenancy. So security zone policy is applicable to many different types of Oracle Cloud resources, virtual machines, object storage, network gateways, database systems, and many others. And with a single policy, you can apply a uniform posture to many, many different resource types, and you can do it very, very efficiently and easily. And I'll give you a demo at the end of this, and you'll see how straightforward that is. If you think about, what are the benefits of guardrails? Well, experts are expensive and difficult to find. Security zone policy sets can help secure cloud resources, and they are, definable as objects and reusable. So if you come up with a security zone policy set that works particularly well for your organization, you can use that over and over and over again as a pattern or template, and you can modify it wherever you need to, but you can essentially capture the expertise of security professionals once, and you can reuse it many, many times across your tenancy, and essentially set up best practices to help secure your tenancy through the use of security zones. Secondly, the second use case that we've talked about is application protection. And what does that look like in practice? Well, let's take a simple example where we've got a simple application with a front end and a back end, and we want the behavior of the front end and back end of this application to be different. We want the front end to be fairly permissive so that internet shopping traffic can access your catalog, your product descriptions, anything else that's important that you're selling. And we want the back end of the application to be secure. We want to make sure that the public and the shoppers cannot access anything to do with the back end. We want to set up more strict, less permissive policies associated with the back end. And so, in this simple example, you could say, what policies would you apply to the back-end compartment of this application? Security zone policies that would be appropriate would be deny public subnets, deny public buckets, deny buckets without KMS keys, deny instances with database instances with public access or without backup. So these are the kinds of things you can do to secure an application, simply by applying security policy to different compartments or different areas of an application to reflect different policy. And then on the third use case is the enhanced high security use case, where you're applying policy to secure resources that is difficult to defeat. And so security zone policies applied to these compartments can essentially constrain infrastructure configuration and changes. You can make some configurations not allowed, and you can make some changes not allowed. You can constrain the movement of resources so that resources can't be copied from one location to another or outside the security zone. And you can constrain the association of resources so that you can't have a backup outside the security zone. You can't have storage or memory outside the security zone that's accessing or reflecting resources within the security zone. And then you can apply service-specific constraints as well. So in the case of object storage, you could say no public buckets. In the case of database, you can say must require backups. In the case of anything that has to do with encryption, you can say requires encryption keys be held outside the Oracle platform. So there's a number of different things you can do here to enhance high security use cases. And, I think in terms of future targets, we're looking at extending service to file system storage, network gateways, and essentially controlling network access to a greater degree than we do today. So we can stop or limit exfiltration of certain traffic. We can also manage immutability, where you can make changes that not anyone can overwrite. You'll require special accounts, special privileges to make changes to security zone policies on compartments if you like. Okay, so then if you think about, compare and contrast these use cases and the relevant features of them, we went through the three use cases: guardrails, application protection, and enhanced high security. Security zones is capable of supporting all of these different use cases, but in each case, the people in the customers, the users, the people using the security zone may want fairly different things. So in the case of guardrails, generally customers want fairly permissive policies. They want to allow their admins to manage security zones. They want to allow their devs to create security zones. That's not really true for an enhanced high security use case. For an enhanced high security use case, generally the customer wants to keep devs from, or stop devs from creating security zones or allowing admins to change security zones or manage them. And simply it's, they're trying to prevent the defeat of somebody with stolen credentials from going in and undermining or weakening their security posture. So depending on the use case, you may have very different needs. Security zones, is designed to handle each of these use cases, and we're actively working with customers on every front here. So then if you think about security zone policy syntax, what is the nature of the syntax and why is it important? What is it doing for you? Well, fundamentally, security zone policy syntax, is always about a deny statement today. In the future, we might change this, but right now, deny statements are working very well for us, because what we do is we essentially turn off certain things that are not desired in your tenancy. So if there's risk associated with public buckets, public subnets, internet gateways, with very simple statements, you can turn off the possibility that those items can be introduced in any way into your compartment or group of compartments. So you can start to essentially shut down or secure certain aspects of your tenancy very, very quickly and easily. And if we decompose one of those statements and we say, hey, what is this statement and how does it work? The action is always deny. There are other policy engines that enable, essentially the inverse, the permit. But the problem with permitting syntax from a policy perspective is that you now have to permit or enable every new user that comes in against your application scenario. A deny statement, you can add a new user, you can add a new resource type, and unless you're contradicting your deny statements, adding that new user or that new resource type will not cause you any problems. And so, in a sense, this becomes a very, very easy thing for a user to administer. It's very, very efficient. And we end up with this fairly simple object verb predicate syntax that is human readable. And we're actually trying to improve the human readable element of it. We're not changing the policy syntax per se underneath the covers, but what we're trying to do is elevate the human readable form so that when you read it, you immediately understand what are we talking about and how is it supposed to work. So let's look at a few policy examples just to get a sense of what these things are and what they do. So the first policy statement, deny public subnets. Fairly obvious, fairly intuitive. Subnets cannot be public. All subnets in a security zone must be private. So the second statement, deny public buckets. It's a really basic concept, but in the world of cloud security posture management, public buckets have caused a lot of problems. If we go back to the 2019 incident at AWS, where the 200 million private records from Capital One banking customers were exposed, it really came down to an attacker getting access to a bucket and recursively copying the contents of a bucket to the public internet. So there's a lot of, object storage buckets historically are very problematic when it comes to attacks, and security zones is a great way to secure object storage buckets so that content cannot be transmitted or copied to the public internet. There's some additional examples of statements that are important or might be very useful for you, but I'll save some of that for the demo, which comes up next. So if we look at customers that have embraced OCI security, I'm just going to mention a couple of them. Ferguson, off on the left, was an early adopter of security zones and CloudGuard. They used security zones and CloudGuard to secure their OCI tenancy. They have a fairly large tenancy with lots of compartments, and security zones provided them a very easy way to guarantee secure posture across a fairly complex set of compartments and requirements. Motorola Solutions, right in the middle, has used CloudGuard and security zones for posture management, and has started to, essentially climb the security posture management ladder from detection towards enforcement, and it's had really good results. And so both Ferguson and Motorola Solutions have provided us with testimonial that confirms their use of these products. So now we're up to time for the demo. So what I'm going to do is I'm going to get out of PowerPoint and I'm going to get into the OCI console. And so security zones is found under identity and security. So when we click on identity and security, you see identity on the left, CloudGuard, and security zones. And these are all things: threat intelligence, web application firewall. These are all things that work together and live together in the console in a common place. If we look at security zones, it's a relatively simple UI that looks very similar to other UIs. The first thing that we have to do is create a recipe. So in this particular case, we're going to create a new recipe, and we're going to call it application backend security zone recipe. And then I'm going to copy that same name and put it in there in the description. And then I'm going to click next. And so from here, I've got the ability to add all types of policy statements that apply to different resource types. And just in the interest of time, I'm going to unclick them all and then pick some compute policies. I'm going to pick some network policies and pick some object storage policies without worrying too much about any one policy. So once I've selected the policies that I'm interested in, I'm going to click next, and then quickly create a new recipe. So I've now got my application backend security zone recipe. The next thing I've got to do is I've got to apply this recipe to a compartment. And so the general structure of security zones, applying it to compartments, is that a recipe essentially is a pattern or template that can be applied to one or more compartments. And the compartments now need to be created in the compartment area of the console, or you can create these things programmatically. And we end up with a series of compartments on the back, underneath each of these high-level things. I'm going to click on the back-end compartment here, and then click Create Security Zone. I'm going to click Customer Manage so that I can use the new recipe that I just created. There's my new recipe. And then I'm going to write Application Backend as a name for my new security zone. And I'm going to copy that name, and I'm going to put it down for description as well. So now I've got my compartment targeted. I've got the new recipe I just created, clicked on Customer Manage. Now I'm going to click on Create Security Zones. And it will take just a moment. While this icon is yellow, it means that the security zone is currently being created. We'll just give it a second to let it complete. It will turn green when it's completed. There it is. So we've now created a new security zone called Application Backend. And we've automatically got our Cloud Guard target also created. So the same policies that are selected for the security zone are then used to create a Cloud Guard target that is parallel to the security zone and provides the monitoring required to ensure ongoing compliance. So you end up with security zones enforcing the policies that you set, and then you end up with Cloud Guard. Here's a Cloud Guard target focused on that same compartment with the same recipe set, providing the monitoring that goes along with enforcement. So we end up with monitoring by Cloud Guard, enforcement by security zones, all done in parallel, and easily managed simply by setting a security zone policy. And then if we click on associated compartments, we've got our backend compartment down below. So this is sort of a demo of Security Zones 101, and the 201 version of this same demo, which we probably don't have time to do, would involve, instead of using a single compartment and applying a security zone to a single compartment, we would apply a security zone to a group of compartments or a hierarchy, a tree of compartments. And so the security zones are very flexible now. And what you can do is you can apply a security zone to a top level parent on a tree of compartments, and the children of that parent will inherit that same security zone recipe. However, you also have the option to go in and remove the security zone recipe from any child's compartment and replace it with a second recipe or a new one. So you can apply security zones quickly to a very large group of compartments. And then you also can go back and essentially modify or change the security requirements for any of the compartments within that tree. So we tried to make security zones as flexible as necessary. If you've got a tree of, perhaps a dozen compartments, and one of them is special for some particular reason, and you need to apply special policy to that one compartment, through security zones, you can easily do that. The most efficient way, you could either apply the security zone policies to compartments individually from front to back, or you could apply a security zone policy to policy set or recipe to the high level or parent compartment. And then after that security zone recipe is applied to all the compartments in that tree, you could go back and you can change or override any of the child compartments with a new security zone recipe very easily as well. So that's easy to do and very, very convenient. So if I go to, let's minimize this. If I go back to my PowerPoint, The next thing that we've got is Q&A. And I can see that I have got a number of questions teed up to be answered. And the first question I've got is, does security zones introduce additional cost? And the answer is no. Security zones introduces absolutely no cost. It is included with your OCI tenancy. There's no additional cost. There's no billing mechanism. It will never show up in your monthly bill, no matter how much you use it. The second question, are these then applied to subcompartments too? Yes, that's a great question. I think the question was asked a little bit ahead of my somewhat lengthy response on that. But yes, by default, the recipes applied to the parent compartment is applied to the children. And that's mostly for convenience and consistency, but you've got the ability to override any of those assignments between security zone recipes and child compartments. You can go to the child compartment directly, and you can create any new recipe that you want on that child compartment. There's a question that says, when are violations reported? As soon as they are detected or at specific intervals like CloudGuard? Okay, so that's a great question. So the way it works, security zone enforcement is essentially done at the control plane level, so that you cannot take a control plane action that violates a security zone policy. The command at the control plane is intercepted and denied, so that anything that has to do with violating a security zone policy that change will not be made. If you ask for infrastructure that's not allowed, you will not be able to deploy that infrastructure. If you try to change a public bucket from private to public, and that's in conflict with the security zone policy, that change will be denied. You'll get essentially an error message through the console when you try to make that object storage bucket public, and it will give you a bright message that says error denied. I'm sorry, change denied. And so the security zone policy enforcement is immediate and will intercept any action at the control plane level that violates security policy applied to that compartment. CloudGuard is essentially not a real-time monitoring solution. It takes some time for those signals to propagate because its reach is very, very broad, and it's listening to so many things that it's just not technically feasible yet to have instant propagation of all CloudGuard detectors back to the console. So I can't tell you exactly what that delay is between how would I put it, a violation occurring that would cause a CloudGuard warning or exception to be propagated back to the user. But in the case of security zones, you don't really have much exposure there, because we've got an enforcement plus verification model where the enforcement happens immediately. So the verification model from CloudGuard, that notification may be delayed by some period of time. Let's say it takes 60 minutes for the CloudGuard notification to appear. The fact that the security zone enforcement is instant and ongoing means that you shouldn't be able to create a vulnerability at all. In fact, the CloudGuard detection of violations is very, very key for us from an application perspective when you first apply a security zone policy set to a compartment with existing infrastructure. So if you apply a security zone policy set to a compartment set with existing infrastructure, we've got to analyze that compartment and look for violations. Security zones will stop any action that would violate the policy associated with that compartment going forward, but we depend on CloudGuard to detect existing conditions and analyze that compartment. So I think that's the only case where there might be some delay between the policy and detection. Can we convert maximum security zones to custom security zones? I love this question. Okay, so here's what happens. Maximum security zones had this concept of absolute immutability, where you could not change the security policy associated with that security zone after you applied it. And custom security zones allows you to change the security policy at any time, provided you've got the right permissions to do so. And so all of the maximum security zones that customers have built, we really didn't want to make any kind of intrusive change that would undermine or impact a customer's existing tenancy. So what we did is we essentially made all of the maximum security zones out there editable without changing the policy or touching them in any other way. So all of a sudden, your maximum security zones that you previously created are now editable and essentially can be transitioned into custom security zones. The only feature that you miss by using an editable maximum security zone is you miss the feature of automatic CloudGuard target creation. So you could essentially close that gap by either creating a CloudGuard target yourself, or you could delete the maximum security zone and recreate a custom security zone, and then the CloudGuard targets would be automatically created for you and you wouldn't have to do anything. But the interesting thing is maximum security zones required that all of the security zone policies be specified before the infrastructure is propagated. So there really is no chance of an existing condition popping up in that maximum security zone, because it's been under the policy enforcement the whole time. So there really is no liability created, but you will find that your previous MSZ compartments are now editable. And we encourage people to, essentially remake those MSZ recipes as custom security zone recipes and reapply them simply to get the benefit of the automatic CloudGuard target creation. But it's not necessary, and you really don't, subject yourself to any security risk, because the maximum security zone started with a clean slate and has been enforced ever since. So yeah, you gain flexibility, you don't really lose any security. Next question, do we plan to offer the customers the opportunity to create their own custom statements as we do with policies? Yes, I love this question, because it's exactly the direction we're headed in right now. We have a fairly large inventory of policy statements that's growing weekly. Every week we come up with new policy statements, and we've designed some improvements to the UI to allow customers to sort or target the UI through policy type and resource type filters. So you can say, hey, I want all policies of type X or all resource type Y, and you can just look at those policy statements. So as we grow from 50 something policy statement possibilities to 150 policy statement possibilities, we'll use essentially a filtered interactive list to choose those policies. And then one step further would be decomposing the policy statements to allow you to assign parameters. For instance, perhaps port numbers. You could start to control network traffic and service gateways by specifying specific port numbers associated with policy statements. And then we looked at the syntax briefly, where we saw that, hey, it's a sort of a noun verb predicate syntax, and we're looking at the possibility of decomposing that syntax so that you can choose your own nouns, choose your own verbs and your own predicates, ultimately creating customer defined policy statements that are essentially, how would I put it, pick list driven, or segments or clauses chosen from a list or typed in that can be composed into an actual policy statement. But that's certainly a future. We don't have that for you today. Next question, if I apply security zone policy now on existing compartment that violates some policy, what happens to these resources like public bucket? So this is great. So I think I sort of touched on this, but the idea, security zone policies by themselves do not detect pre-existing conditions on a compartment with existing infrastructure. We depend on CloudGuard to identify those places where the policy and the state of the compartment infrastructure have a problem. And so when we detect those places where the security zone policy applied and the state of the infrastructure in that compartment are in conflict, we create a CloudGuard problem. And we've utilized the CloudGuard problem UI and also the resolution path for CloudGuard problems. We've utilized that same infrastructure in the development of security zones so that we now propagate those existing conditions that are found as CloudGuard problems for the user to address. But that's a great question. And when you apply security zone set to a new compartment, to a compartment with existing infrastructure, there will be a little bit of time delay before CloudGuard finishes the analysis of that particular compartment. So you should give it a couple of hours to test it out and see what comes back. And then once those problems are resolved, like in this case, if there was a public bucket that was exposed, you'll be able to go back and remediate that, and the CloudGuard problem will go away, and then you'll be in compliance. You'll no longer see that warning. But right now, the way it is, you'll see that warning flag propagated in the security zone UI until it's resolved. So you'll keep seeing the red flag warning of, hey, public bucket inside the security zone. Okay, I'm looking at all of the questions I've got. I think I've gone through all of them. We are finishing just a little bit early, but I think that is all that I had for you today. So I want to thank you for your time. Thank you for your questions. I appreciate it greatly and appreciate your attendance today. Thank you very much.